REST before now. GraphQL was released by Facebook. And then right now, there's been a serious heated argument about which one is better. Is it REST? Is it GraphQL? And I think Christian's talk is just going to quell all the answers, all the questions we've had concerning these two technologies. So take it away, Christian.
Hi everyone. Okay, let's get settled so we can talk about this guy called GraphQL. Okay. So I always ask for a favor before my talk. Two favors actually. The first one is that give me a round of applause. It's so hard to come to this stage, so please. Thank you. And the second one is, even if I don't remind you, please just be nodding your head. It gives me encouragement, like I'm making progress. Okay? Yeah, thank you. So, and GraphQL versus REST. In my own opinion, the best way to talk about a new engineering tool is to compare it with its successor. Okay? Which at this point we're comparing GraphQL and REST. So, generally, we're going to cover the following. We're going to have a recap on server-to-server networking. Like, it's something we basically know, but I'll just show you a diagram on how things work so you can refresh your memory. And then we're going to compare SOAP, REST, and then this new girl called GraphQL. We're also going to consider why REST is not the best networking standard. Okay, I know it's something we are very used to, but we're going to talk about why it's not the best networking standard so far. Lastly, we're going to discuss the fundamentals of GraphQL. I'm not sure if you can see some code examples because the time is so short, but I plan to show some code examples if we have enough time. So at the end of this talk, instead of treating GraphQL like this, at the end of this talk, instead of treating GraphQL like those cats, like the way they're curious, trying to find out what, this is how we basically relate with these are relationships with new frameworks, okay? So instead of treating GraphQL as like those cats, we're going to leave the hall like those ladies. Yeah. So hopefully now that I've gotten you excited about GraphQL, let me introduce myself quickly.
Still the same avatar.
Yeah, so I'm the guy with the same avatar, and my name is Christian Code Beast Nwamba. So I'm officially taking that name as my middle name. And I'm a developer advocate at Cloudinary. I'm co-organizer of ConcatenateConf. I also help organize Follow Up Africa with Prosper and other organizers. And I'm also a front stack co-organizer with Ire. I'm also an author, yes, I wrote 2 books, yeah. Thank you. So, like most engineering solutions, the best way to understand the problem they're trying to solve is to look at the existing issues that we had previously. Okay, so we are going to actually like have a recap, take a look at history, and look at how server-to-server networking work fundamentally. Basically, you have a client, and when you hear the word client, it doesn't have to be like a laptop. A client can be a server as well, right? So you guys can nod your head so you can encourage me. Yeah. it can be a server, it can be a laptop, it can be a phone, and then this client makes a request to a server. Okay, the server processes the request, probably does some data and storage, and then it responds with a response. Okay, this is just a blueprint. It doesn't show you how anything works. It just defines what the picture I show you doesn't make a request. It doesn't respond with any response. So how is the actual process completed? Does anyone remember SOAP? SOAP, yeah. I know we are 90 kids, so we won't actually like know what it is. But SOAP stands for Simple Object Access Protocol, and the simple in the definition is a very big lie. Yeah, like it's the biggest lie I've ever heard. And it's based on XML for the Android developers here. You guys know how heavy XML is, okay? Yeah, it's really heavy. So compared with this other guy called REST, does anyone know REST here? Yeah, I told you are 90 kids. So REST is very gentle on the brain, okay? It's lightweight, it's JSON, so it's very, very lightweight. It's descriptive. You can easily tell that we have a table here with 2 rows, right? And it uses verbs to like describe requests. So when you hear things like get or post, it's really descriptive to tell you that get is fetching a request and post is making a request to a server. So in that case, why not just REST? Okay? Yeah, so from now on to the end of this slide, I'm basically going to be telling you why you should not be resting. Yeah. So there's an issue called underfetching versus overfetching content. So let's have a look at this illustration. Let me paint a picture for you. Assuming I have this client, okay, that's making a request for a user. So I have a request, I have like a //user/ID. So it makes a request to a server, okay? Then the server processes this request and returns a JSON payload, right? And then that JSON payload is sent back to the client. What if I actually need that user's post, not just the user? The server tries to make, the client tries to make a different request, okay, to the same endpoint. And let's assume that endpoint was now designed to return a user's post. If you noticed, the first question we would have asked is, why we probably have 2 endpoints. You have one making for the user and we have one making for the user's post. Why not just have one route that fetches the user details and includes all the posts that were submitted by the user? But then there's an issue. If we include the posts as part of the response, and the client doesn't render those posts, assuming they're just creating a profile page where you just have the username and the name and the email, what we call overfetching occurs. Okay? So we'll have an array of posts that ends up being useless to the client. Am I painting a picture? Just nod your head. Yes. And at the end of the day, you have a negative impact on your application because you're basically fetching a lot of data at the end of the day you're not making use of. Okay? But then if we now decide to go the other route and just fetch what we are doing already, we just fetch the user differently and have but then fetch the user differently, and then if the post is needed, we get the post. But then what if I fetch that user? The client doesn't have, you have to like define specifically that you need the user or that you need the post. Okay, so if we fetch just the user's information without the payload, and then at the end of the day, the client needs the payload, another request is made. So we'll have something called underfetching happening. So I'm making a second trip to the network to fetch that resource, to fetch a resource twice, which you have fetched the first time. But then you fetch the first time and it's not needed, overfetching occurs. So like you have like a bit of a big issue that you can't actually like easily escape from. So I had this slide, this particular page, and I asked Sarah Drasna to help me to review the slide, and she said I should tell you guys that if there's anything you take away from this talk, it should be this. When you're designing an API, you shouldn't design an API. It's best in my opinion, and probably in another person's opinion, that you design. Sorry, Rotimi is trying to get me another avatar. That's why he's standing here. so, so it's best you give the client what it needs. Don't give the client what you think the client needs. So when you're designing API, basically, let's say I'm designing a blog API. I have a post endpoint, a user's endpoint, and stuff like that. Don't, and in the users slash ID, just give me the user information. Don't try to like include the post because you think, oh, maybe at the end of the day, the client might need to render those posts as well. Okay, but then it's not as easy as it sounds to like have a single endpoint for just a single resource. So I'm basically saying if I need an email, if I need a user ID and the user's post, don't give me the user's email, don't give me the user's name. Just give me that ID and the user's post that I asked for. I'm basically asking you just, how can I ask a server to just give me a particular information from the database without requesting every other data that is not needed? There are even more problems apart from underfetching and overfetching. We have the issue with schemalessness. REST as a means is too flexible. Okay, so validation is hard. The only thing you rely on to tell you how the structure looks like is documentation, right? You just have documentation that says that the user resource has name and email and stuff, and things can break. The developer can just wake up when they remove the email, and the documentation still says that the email is there. So it's actually very hard to like have validation going on. So it's just so much flexibility for building systems. And as I already mentioned, APIs are so reliable for things like this, and API documentations are so reliable. On the other hand, we have prototyping friction. REST as a protocol now is too inflexible. Okay, I have /users /ID/post, and then someone wakes up tomorrow and a user wakes up tomorrow and then we have a new user story. The whole idea changes. The UI, just a change on the UI has a high chance to affect the structure of your API. Okay, it's something we normally encounter in our workplaces. Structure generally, it's just difficult to like keep a good it's difficult to have a rigid structure when prototyping, and then at some point you need something more flexible that you can just ask for what you need from the server, and then the server gives you what you need. So what if we had a type system? The way in C# you have classes, interfaces, and stuff like that. What if we had something like that for REST? Okay, like a type system, not just for the language, but for the standard, for the protocol, for making a request. And what if you just had one URL endpoint? Like, why do we have to like have at a page you have a full list of documentation with a lot of URL you have to memorize as the front-end developer? What if you just had one endpoint and then a data structure, a type structure? And if you just had that one endpoint, what if we could make all queries and all mutation directly from that endpoint? It sounds impossible, but what if we can do that? And what if you had a way to self-document our APIs? Like after building a new feature, we don't have to write a new documentation for it. It self-documents itself. So say hello to GraphQL. So we're going to go through the GraphQL fundamentals, and that's all. GraphQL uses a language called SDL. That's the only way you can have this type, and the type language I was talking about. What if we could have a type system for GraphQL? So we have SDL, which is this mic. We have SDL, which is the language for GraphQL. It's basically the language for GraphQL. And it's a type system. It serves as a contract between the server and the client. So whatever the server defines as the type, if the client doesn't adhere to those instructions, an error is thrown. So if SDL is the language for the type system, what does the type look like? this is exactly what a GraphQL type looks like. So you have something like an interface, like a structured programming language interface, where we have an identifier, okay? You have the name of the type. In this case, it's called to do. We have the fields. We have an ID, a task, and a created fields. Just like the way you have properties in objects, those are what fields are for. Then we have the field types. So you can see types in play. The type itself is typed, and the types fields are typed as well. So the ID is a type called ID. The task is of string type, and the created field is a datetime type. And then we also have this question mark that says that that particular field has to be non-nullable, so it can be empty. And then we have directives. So the directives are GraphQL specifications that allow you to extend the existing type. So we're basically saying that this particular field should be unique. There are other types, apart from what you've seen. We have three major categories: the scalar types, the custom types, and the other base types. So the scalar types are the primitive types that you know from other languages, where you have integer, string, float, datetime, and boolean. The custom types are the one you create for yourselves. So like in structured languages, you have C#, you have classes, and those class names, in this case, or interfaces, those interface names are the custom types in GraphQL. So just like the to-do we created in the previous slide, in this case, it's a custom type. A custom type can be a resource in your application. So there is to-do, there is user, there is post, there is cast, there is animals. It can be anything. Then other base types, which are GraphQL defined, are things like interface, enum, mutation, and query. And you're going to see the differences between those base types now. So these are what custom types look like. You've seen them previously. We have a person types with different fields. We have a comment type with different fields. And you can see we are building a relationship here. The comment, the person can own multiple comments, and a comment can be owned by one person. Okay, so you can actually define relationship in your SDL, in your schema definition language. I spoke to you about base types, which I mentioned query and mutation. So this is what a query looks like. You cannot directly interact with your types. So I can't directly ask for the users. I can't ask the users types to give me the list of users. I have to define a query, which at the end of the day looks like what you have when you have an express callback. Do you guys who uses express here? Yeah, you know what an express. I'm trying to. If you've made a request, if you've like processed a request on a server, there's always a function that handles that request. Okay, so the query defines a type, and that type at the end is translated into a resolver. So at the end of the day, I'm going to have this task be a function that's going to return an array of tasks. Okay, and then this is what it's going to end up looking like. The normal JSON you need, but at the end of the day, you can just define what you need from. You don't have to list all the values of to do. You can just ask him for the task value or the name or the ID. Okay, you can see we're not overfetching right now from what you have on the screen. Then there is another type called mutation. When query serves for reading values from the server, mutation serves for writing values to the database. So you can have a mutation called add to do. When the mutation occurs, it creates a new value in your database and then returns a response, just like the usual REST endpoints that we'll have. I was supposed to have a demo. For 4 minutes. I can't. I'm not sure I can. I was supposed to have a demo, so I have to like show you guys how to set up a GraphQL and stuff like. But then we end up having just 5 minutes for the talk. So instead of taking the demo. Feel free to ask me questions. It doesn't have to be what I spoke to about at the talk, but relating to GraphQL. So we can use the next 7 minutes to answer them.
Are you done with your presentation?
Yeah.
All right, questions, please. Okay.
Amazing, crispy, clear presentation, code based.
Yeah,
Great
thank
work. Straight. I want to get up and running really quickly. Prototype an idea, get it out. Prototype an idea, get it out. At the same time, knowing that once this hits, I want to leave it for developers within my ecosystem to work with quickly and manage. If you're in those shoes, what would you do? REST or GraphQL?
Did you get this question? I'm not sure I heard it clearly.
Okay, so the question, basically, REST is very unknown. REST to speed. QL has this learning curve and this boilerplate code that you have to work within client and server. Get up and running really quickly, really fast. What would you use?
Did you ever write SOAP? Did you ever write SOAP? When you wanted to learn REST, was the learning curve smooth? Yeah. Yeah, so it's just a general problem with new technologies. There's no quick and way out of. The only thing that's actually been so fast for me to like move with is Vue. That's the only framework. Advice is this.
From REST, because for example now, since GraphQL provides tooling that makes development easy, like the GraphQL, and you inspect the dev tools, what you end up seeing is not so much different from if you're making an actual REST request. So is it that it's different, or it's just REST on steroids?
Yeah, I think that's the best way to put it. When people hear REST, we pay so much attention to things like HTTP verbs, things like get, post, put, and stuff like that. Okay, when I say REST versus GraphQL, I mean GraphQL versus get, post, put, delete. So at the base of GraphQL, it just uses HTTP requests. You understand? And then it returns JSON, which is basically what you do with REST. But
for example, you now have to of your website. Why are you guys laughing?
Hi. So you said that
what the stuff there's nothing like it's at the resolver level, not at the route level. Does that make sense? Have you used GraphQL before? Okay, just know that there are functions that handle the queries you make at the server, and those functions are responsible for authenticating your request.
All right. My name is Fred. I think GraphQL is really awesome. Into your.
Don't allow Prosper to answer.
I'm not going to talk too much.
No.
I'm just going to give you straight.
No,
all right.
Okay.
So at the point where you're thinking of incorporating GraphQL into your product architecture, is when you're looking at moving or iterating very fast between your product teams. So you have your backend engineers normally, right, building your API services. Then you have the front-end developers. Now these two guys think differently. These guys are building the microservices. These guys are building the stuff that consuming those resources, right? And one thing you discover about REST is that when a new feature comes up, you have to wait. If you're using GraphQL, all of you guys are moving together, because before you even move, you guys look at the schema. You have a schema that is binding the client and the server, and you agree on a contract that this is what our schema is going to look like. Whether it is backend or frontend, it works both ways. So two of you already are aware. So as you're adding a new feature, you're just what? You're changing the schema. And once you're changing the schema, the only other thing that you need to do is just to add a resolver function, and you're done. And then you guys are moving fast. Any questions?
Yeah, just one last question. Yeah. Yeah, just give him.
Just, okay.
Thanks. Thank you for your talk.
Yeah.
So I feel like one of the biggest advantages for REST was that there were standards. So if I was making a get put post request, there are things I'd expect, and like so browsers could be optimized to handle important.
I think I've answered to that.
No,
It's just very
no.
simple.
I'm the speaker and Prosper is not answering. There's no more time. Yes. Yeah? So you said, let me get to the question. The second thing you said.
How do you undo status codes in GraphQL?
They're picturing the way REST works as where you have a property, a table where you define an endpoint and define properties to that endpoint. You remember, that's the thing. So that's what standard does to you. Standard makes you think in a small box. Okay? So that enforcement is not strict to, the web is free. Like, should be you are writing HTML and JavaScript differently. Now you're writing HTML and JavaScript. The standard was write them differently. You understand? So that standard is not, it can be broken, and then you can have like better ways of doing things. There's an improvement. Yep. Okay.
I think one way that you can just optimize for that, if you really want to get that functionality back, you know when you're getting your GraphQL responses, it just gives you the error. So now, if you built your server using something like Apollo server, it comes, the latest Apollo server 2.0 comes with what you call different types of error classes. That for each error classes, you have the forbidden error, you have authentication error, you have the different types of error that you can enforce. So that when the GraphQL responses come back, since by default you don't have a status code apart from 200, you can now specify that this is the type of what? Status response that you should return with the status code. Okay, so when you look for the Python implementation, which is Lysine, it's not Lysine that you guys use in Python for the GraphQL. Graphene, right? I don't know for the implementation of Graphene, but I think you can also submit a PR as a spec that can go into Graphene and then into other functionality. Then concerning the authentication aspect, I have a